So, hello everybody. Welcome to the January meeting of SFCDI. So as you know, we have a website, we have email, and we have Twitter, so you can follow us on those platforms to see any of our future events. We also post our previous events on our YouTube channel, so if you ever miss any of our events, you can go and look at them later. As always, you can sign up for monthly announcements at our website. When you sign up, you're put on our email list, but you can feel free to opt out. Remember that all online attendees are muted by default, so that if you want to write questions, please write them in the chat channel so that we can answer them later. Yeah, feel free to provide any feedback you might have. So just an announcement for our next meeting. We'll have Marcelo Scambaluri presenting about Rhino Inside, which is a really exciting tool that you can use to put Rhino into another application such as Revit. It's a really great tool. It's usually the third week in February, so about a month from now. 21st? Okay.
I can sign up for it now.
Soon.
Yeah, you can.
You can? Yeah, it's on Revit, right? We are also working on a workshop on machine learning. We'll be in partnership with Peter here. You can sign up. It'll be on March 25th at 5 p.m. to 9:30 p.m. So that's really exciting. I think Alberto is also going to help with presenting on that.
Yeah, and also in February, we're going to host Robert Otani from Fortunato.
Can you?
Yeah, he's a VIP for principal and CTO. If you may know someone who can be interested in your company, he's coming directly from New York, and we're gonna have the 14th here at AIA. It's gonna be a really cozy roundtable, and it's gonna come here, so we're gonna welcome him. If you guys know Torto Tomasetti, the core group, and that's gonna be a really nice VIP roundtable. Feel free to email us so we can provide you more detail if you're interested. It's gonna be a cozy one with 20 people probably.
Thanks so much, John. And so we want to thank our sponsors. We want to thank AIA for giving us the venue here. We want to thank Gensler for providing us with the webinar, and we want to thank Layer for providing food. The pizza is really nice. And so our first presenter is Tom. Tom is an architectural designer and researcher based in Copenhagen. He's been focusing a lot on emerging technologies and revealing new modes of material practice. And so I'm going to hand it over to Tom, who can give a more thorough introduction if he so desires. So take it away, Tom.
Thanks. Can you guys hear me okay? Hello?
Yeah, we can hear you just fine. And I'm going to give you presenter right now.
Thank you. All right.
Okay, so we can see your screen. We can see your PDF.
Perfect. Is this still good?
Yes, you're good.
Perfect. Yeah. First of all, thanks for inviting me. Sorry, can you just mute the microphone? Get rid of that echo. Perfect. I'm Tom. Sorry, Zach, can you just mute that microphone, please? Thanks. Yeah, so since I only have a little bit of time, what I'm going to show today is just kind of an overview of the work I've been involved with, a tiny bit about my background, and then some of the stuff we're working on right now at SFCDI in Copenhagen. So just as a bit of an introduction, I'm Canadian. I did my master's in London, and I guess I've always been interested in this sort of translation between model and the different types of data and steps in between that lead to the final sort of material effect or architectural effect. And in that sort of capacity, after my master's, I worked for some companies that did 3D scanning and immersive media, a bit of VR tracking, that sort of stuff, as well as sort of experimental robotics and performative stuff and building pavilions. Yeah, so with a company called ScanLab, we did like photo shoots with 3D scanners and got to go to some interesting places with this kind of, at the time, quite a new technology. So LiDAR scanning and trying to kind of misappropriate it or use it for things that it wasn't supposed to be used for. Yeah, by the way, if you guys have any questions or if you want to stop me, feel free just to stop me and ask for any comments. My work after my master's led me into more fabrication and robotic fabrication, and especially how to integrate new technologies into, let's say, material processes that were largely traditional. So this was an example of where we started using simulation software and live motion tracking in order to try to match the kind of material output of a laminating process to the simulation that we did. And that was the kind of seed for what I'm doing now, which is a PhD. So just to give you a tiny little background about SITA. SITA is the Center for IT and Architecture. It's based in Copenhagen, Denmark. And its main sort of mission is to examine how digital culture is impacting material practice. So how digital technologies, how emerging technologies are affecting the way that we make and design space, and especially how do we work with materials. So a lot of the projects that SITA has done have been centered around material behavior and ideas of trying to simulate that and trying to develop these sort of kind of reflexive relationships between design, modeling, and fabrication. And it's been involved in a lot of research collaborations throughout Europe, as well in North America as well, and different partnerships and publications. So, for example, the image on the right is a bridge made out of super thin metal panels that have been incrementally sheet formed robotically to have stiffness and strength exactly where it needs to be. My PhD project sits underneath something called the InnoChain project. So InnoChain is a research network that was started about 4 years ago. It's a collaboration between 6 different academic institutions across Europe and about 14 industrial partners. And the main sort of gist or brief behind InnoChain is it's challenging the linearity or the linearity in the design to production process. So how do new technologies and how do new material processes affect the way or challenge the way that we think and design today in architecture? So these are the partners. There's SITA, there's the BILT in London, ITKE in Stuttgart, the Institute of Architecture in Vienna, KTH in Stockholm, IAC in Barcelona, and then a mixture of architecture firms, so Foster and Partners, White, Big, and smaller companies, software developers, as well as producers such as Bloom & Lehman. So in my project, I've been working with White and Bloom & Lehman, and I'll explain exactly how. So my research starts very simply with the kind of basic premise that wood is the oldest building material, or one of them anyway. It's very well understood, but the introduction of new technologies lets us see that in a new light. So we're seeing the world around us with new eyes today. And similarly, there's kind of romantic notions of woodcraft and craftsmanship and timber and all this kind of stuff, but the reality today is very different. So this is a production hall at Bloom & Lehman, where they basically chop up 20-meter long massive glulam beams for Shigeru buildings, for example. And as well, everything's becoming digitized, and we see this kind of confluence of model and material reality, and the kind of integration of all these things together in one sort of messy space. And the kind of architectural output is, one example is, highly complex, very large scale buildings, very highly engineered buildings out of wood that are really challenging the material performance and behavior of wood. So that's the kind of starting point for where my research came out of. So out of this kind of desire to see where this takes us. So how do all these new technologies and processes affect timber construction? So being between White and Bloom & Lehman conveniently positions the project between architectural practice and architectural production. So Bloom & Lehman, they have a sawmill, they're a fabricator, a contractor, and white is Scandinavia's largest firm, spread out across all of Scandinavia, and it's very multidisciplinary, very horizontal, very distributed, but it's it's an architecture practice. So the idea is, then how do we bring this kind of knowledge and material consideration from the late stages of a project into the early stages, and how can we kind of expose that as a space of design? And just to briefly go over this, and in my research that's kind of done in 3 ways. So one is by modeling. So if we kind of preempt problems or preempt the material results by being able to predict the impact of design decisions, then that helps us. And then also, if we understand the sort of value chain behind timber products and glulam's and all of this, that sort of also opens it up as a design space and allows us to design more specifically and more, let's say, in a more tailored way. And then the final thing is brokering. So how actually, how do we spread that knowledge between contractor and the architect, and how can we start to kind of involve the people and transfer experience, which is oftentimes quite tacit. Yeah, and in terms of modeling, that comes down to how do we codify a lot of material principles and behaviors into something that's computable, representable, and that's something that we can use in a very real and data-centric way. And for prototyping, that's about exploring this material design space of glue lamination. Yeah, and of course for brokering, that's about connecting different knowledge domains together. So it all starts with this. As we all know, wood is organic. It's very fibrous and heterogeneous, and that means that it has a very high directionality. So this 5-degree sort of line is, after that point, the strength of wood dramatically falls down. So let's say if you align a force with the fibers, wood can be incredibly strong, but it's about a tenth of that if you're applying force across the fibers, for example. So there's this directionality that leads to very many of its sort of challenging aspects. And then if we look at the material palette today in engineered wood construction, you have lots of bending, big wood glulam presses, CLT, multi-axis machining, and all these. That's a kind of like material palette for working with. So as part of my research, then I looked at different alternate types of glulam. So what happens if we go back to the glulam process and start to challenge how we actually put glulams together, especially freeform glulams? They're geometrically complex. They're used in quite demanding applications. It's very niche, but quite important for when you're trying to maximize the performance of the wood. So this is looking at different types of sort of speculative glulams that could be used to kind of challenge that process. And then as well, how do we start to kind of interface with them and see them in terms of the model, and how do we get them back into the computer? So this is one that was using kind of offcuts and short straight pieces and laminating together, machining them back, and then laminating another layers over top. This is another one where instead of lap joints that take away half of the material at every joint position, we are using the glue lamination process to interleave the lamellas in a way, so kind of weaving the wood around joints and trying to make that very strong. And the whole time simulating this and trying to kind of attach it, relate it back to the model and compare the performance of it. And it led to very simple questions as well, like, so what happens when a glue lamp splits or branches out? And by working very sort of haptically as well as digitally, we could start to explore that. So obviously we need to model this. We need to somehow compute it. And a large part of that work was how we can actually transfer very simple principles to and encapsulate them into models that are very easy to work with. So on the top, there's different considerations like the axis of the wood in each lamella, and then the overall axis of the glue lamp cross section, for example, as well as adjusting lamella size based on the curvature and distortion of the glue lamp blank. So if we have a very three-dimensional piece, the more curvature there is, the smaller each piece needs to be, and the smaller each piece needs to be, the more waste there is in the wood production process, and the more complexity in fabrication, and so on and so forth. And the bottom is just trying to avoid spaghetti and encapsulate things as simply and cleanly as possible, for the specific purpose of doing glue lamp projects. There's also the issue of scale. So if we look at individual pieces, how can we start to represent things like fiber direction on top of geometry? Because you can cut anything out of a block of wood. but how do you kind of retain that information about where the fiber is going? Because that's incredibly important. So that was also, developing modes of representing this kind of extra geometrical information on top of models, both at the material scale of, a single piece of wood to the glue lam, and then further on towards structures as well, and implementing things like graph-based modeling to manage complexity in those kind of cases. So it was about developing this sort of data model that could handle references to all the stuff. So the sort of design element, the glue lamp blank that covers it, the joint details, the composition of the glue lamp, and so on. A lot of that's just exposed on GitHub as a kind of research toolkit. So feel free to have a play. No guarantees of robustness or anything like that, but as a tool, it's been we've used it then for certain projects and for developing glue lamp specifications for or estimates or cost estimates for glue lamp projects. The red here, for example, is looking at surfaces that are cutting too much across the fiber. So those surfaces will have a lot of exposed end grain and therefore be quite weak and non-durable. So just to show you some examples where where this was kind of deployed. This was a competition entry in 2017 with a colleague of mine at CETA, and it was for this kind of large canopy structure made out of all these branching freeform glue lamp types that were a bit of a kind of a mess. This kind of like very dense growth of branches and kind of branching structures. But what the tools let us do was very quickly analyze the feasibility and fabricability of these kind of elements. For example, on the top right, you see one of the legs, and then the green is the center line basically of each little glued wood piece, and the red says where it's kind of exceeding its bending limitations. So what these tools allowed us to do was to very quickly, at a glance, assess a very complex and quite crazy structure. And then kind of base our decisions off of that. So on the left, you have a kind of visualization of what the structure could look like, but then the real model is actually that on the right, which is the graph, which kind of gives us much more information about what is going on. And one of the things that sold the project to the jury was that we could very easily zoom into each element and kind of have a good overview of the complexity. We didn't win, obviously, but we got good friends. And then another part where I guess computation has been used in my work has been in kind of directly in the material. So kind of coming back to some of the pictures I showed with the scanning. This was developing some experiments at Bloomer Lehman to confront this problem. So they have these kind of massive wood spaghettis sitting on the machine, and they have a production model, and they kind of have no edge or anything that they can align it to. So often they have this problem where they have the material on the machine and they don't know where exactly it is in space. And what I was helping them there with was testing different kind of systems. So real-time optical tracking, LiDAR scanning, and kind of homemade, spindle-mounted scanning to be able to register them. And that was about, in my research, that was about trying to find that link between what the material is doing on the machine and fabrication model and the production model. So in an ideal world, if we took that further, it would be responding to every single kind of spring back moment during the machining process. But we didn't quite get that far. But this is kind of setting up that link between what is being produced and what is in the model. How am I doing for time? Is it still okay? Okay. And then just the last project was with White, where we were looking at this bridge proposal. And the project started very simply with a set of parameters. It was supposed to be a pedestrian bridge over a road and some railway tracks, and as part of like a much larger development. And the architect team, as well as the client, they just kind of put in this kind of bog standard concrete loop that was going over the bridge or going over the road. And I spent some time with White, and we basically tried to put together a concept or enough of a development to pitch the idea of doing it out of wood and what that would look like. So part of it involved scanning the site, putting in all the constraints and developing just a very basic parametric sort of, constructing the parametric, situation or scenario where we have these kind of zones of clearance, very important trees that we have to miss because they're protected, and slope constraints, obviously, and things like that, maximum or minimum radii for any kind of turns in the bridge and so on and so forth. And that developed into to taking that initial sort of concrete loop and then putting a wood structure and starting to look at in more detail about how that would work as wood. And a lot of that was just based on principles. So just as soon as it went into a timber building, it developed into a focus on materiality and durability. So that was the biggest switch in the project. So obviously with wood, there are much different considerations than with concrete, for example. But that started to kind of change the nature of the project. And then we went in again with these computational tools for glue lamps and started to do little assessments and little tweaks to see how we can go from something that's quite curvy and non-standard to something that's much more rationalized. So on the top left is all the red is double curved elements. And because those are about 10 times more expensive than those straight elements or even single curved elements, we want to get rid as much as possible. We want to get rid of those as much as possible. So just by making little tweaks and working between knowing what kind of glue lamp we need versus how much we can machine away and what the waste percentages is of all that, we kind of arrived at something that was much more feasible. So it helped to kind of construct this a case for doing a timber bridge, which was taken on very well. And then as part of the research, I took part of that further into saying, well, what if this was made up of entirely of glue lamps that were very directional and could really that were double curved, and we didn't really have to rationalize for the producer. We could play with these freeform glue lamps and these kind of splitting and branching glue lamps and see where that takes us. So it was again using that toolkit for assessing the model and looking at material specifications, finding out exactly how much wood needed to be bought, what the segmentation is doing. So you can't have with the tools I had available, I could have 10-meter beams. I could do 2-meter beams. So everything had to be segmented properly into bits, and then keep track of all the joints in between, and so on and so forth. And then there was a bit of prototyping. So again, there was all the all the machining data was generated from these models that were related to all the other elements, and they were located and sort of registered through 3D scanning. And the work I did with Lumi Layman, there's your Faro, there's your 5-axis mill. And then it resulted in this little material prototype for the in-chain exhibition. So that, in a nutshell, is what my research is about. This last one is just super quickly, just some current work that we're working on, which is kind of reaching back further into the value chain. So if we think of architecture as being now able to interface with the design of glue lamps, now if we take that even further and go back to the sawmill in the forest, we get some more interesting stuff. For example, now these days they're starting to put CT scanners in sawmills, which means that you have this massive data set of for every single log that goes to the sawmill, which opens up new possibilities, right? So instead of just grading individual boards at a time, you can have very localized and very specific notions of quality and use across the log, across the tree. There are just some pretty amazing images just from digitally peeling back these data sets of CT scans. And what that basically led to was if we start using more of the tree in a much more strategic way, we can start to assign sort of performance demands versus the available quality in the whole tree, and start to kind of match the design to the actual distribution of the cuts of the lumber in the log. As a first step, this has just been kind of a sketch just to show, around joints, we need a very high quality wood, but in the same plank down, further down could be worse. And in the middle of the beam where we don't need that much quality, we can have parts of the wane and parts of kind of, worse quality wood. And what that allows us to do is just be very specific in how we allocate material based on design drivers and design demand. Yeah, so just to leave with that, what I think is some of the conclusions or thoughts that I've come to is that what this leads to is a specificity. So it allows us to, all these technologies allow us to engage with the site and material at a much higher resolution. We can be more specific, we can be more tailored. it also leads to awareness, or kind of calls for this kind of awareness. So we can be more sensitive to material behavior. We can react to uncertainties. You know, it's not just purely top down. We can be adaptive, and finally it kind of fosters this sort of engagement with the rest of the value chain. So it's sort of promoting integrative design by not just stopping at the contractor, but kind of trying to go beyond into the whole value chain and extract useful methods and processes there that could hopefully make design better. So thank you very much. Oh, I can't hear anything.
Sorry, can you hear us, Tom?
Yeah, all good.
Okay. So I'm just asking for questions here. I'm looking online. If we have any questions there. I don't think I see anything.
Are there a way for US companies to collaborate with the European Union for Horizon 2020 for this kind of research project?
Not sure about 2020. I think, to be honest, I'm not sure. Something that I've come across that has some European, and I think there's probably some rules against flying outside. I'm not sure, to be honest.
Okay. Well, then we can come back for more questions later. So we'll move on to our next presenter. So next we have Zach Soflin. He spent nearly a decade promoting and leading computational design and innovation initiatives in practice before founding Layer, which is an AEC startup company that he leads. So I'm going to give the presentation over to him, and then he can take it away here.
Awesome. Thanks, Dennis. I'll, let's see.
Okay, good. So go for it.
Awesome. Okay. Thanks, everybody. I'm Zach Soflin, and today I'm going to talk a little bit about a few case studies, actually one specifically that led to the creation of our product. So I'll get into what Layer is here in a second, but first I want to kind of give you a background as a kind of entry point into where this all started. I was a practicing architect for about 8 years prior to founding Layer, and at a firm called BVH Architecture. Oops. There we go. Okay. So BVH Architecture is a firm of about 50 people in the middle of Nebraska. They worked on projects of all sizes. I was a project architect for them, and I really focused on projects from start to finish, but then kind of taking my role within that project and implementing computational strategies of whatever was needed for that specific project. Mostly, like, a lot of our clients are really pragmatic in their needs. So like, it was really focused on efficiency and like building performance, things like that. So like, for example, this is the Haymarket Arena, and my role was literally just to manage this outer skin and the structure behind it, so that we could go through iterations. So this is really about efficiency, all the way to like smaller scale projects, like the Nature Conservancy here, which is a meeting center out in the middle of nowhere, in the middle of 60,000 acres of conservancy. And this is really focused on like building performance and energy performance itself, and doing fun things, fun little projects like this IO desk, which basically is made up of 18,000 wood dowels, and was basically a way to kind of crowdsource assembly. We created little assembly sheets, and 35 people kind of helped us assemble this thing over the course of 3 weeks, pounding wood dowels into a surface. Previous, like at BVH, I mean, I really worked on all kinds of items, but really focused on design technology and how we could integrate that into the projects we were working on. One project in particular that I was put on was a project for the Nebraska State Capitol, which was a 10-year HVAC replacement project. So which meant we had to oops, too far. We had to go into every place within the building, rip out the old HVAC equipment, replace it with new stuff. And along with that came a lot of like need to patch and repair and figure out what's preservation worthy and what's not, things like that. And so the part of this solution that we had to do as part of this project is go in and actually figure out what's in the building, and that led us to have to do a full conditions assessment of the entire building. So we had to go into each individual room, take a look at each individual window. We gathered about 57 different data points per room, 20 different data points per window, meaning like we were walking into a room and saying, all right, what's the wall material? What's the condition of that material? Is it preservation worthy or not? Is there casework in here? Things like that. Basically getting a full picture of everything within the building itself, and everything related to the thermal envelope, the windows and whatnot. Not to mention we captured about 39,000 photos of the building. So this is a lot of like real world data that we are gathering that typically would have just been housed on a server somewhere, and hopefully we'd be able to find what we were looking for. So this was our typical process up until this project, which, you know, we're walking out with a clipboard in the field. We'd have a form, we'd walk into each room and jot down the answers. We'd proceed to take a bunch of digital photos of the area, and then at the end of the day we'd come back to the office and scan these papers in, download the digital photos, put them on our server somewhere, and hopefully, you know, months or even years down the road when we actually needed to utilize that information, we could find what we were looking for. We knew that the scale and multiplicity of this project wasn't going to allow us to approach this in the same way that we had before. So we started looking for a different way to approach this and a different solution. What we did have was a really detailed Revit model. So we had spent a couple hundred hours out in the field measuring and inputting all this information into a digital model. What we were missing though is that connection to all that real world information we'd collected and the design tool that we're actually producing our drawings in. So to put it succinctly, like the information that we needed to design wasn't connected to the tool that we actually used to produce our designs. So we had all this really valuable building data, but there's all of these hurdles between accessing that information, understanding it and its context, and then translating it to our actual design. And so we set out to kind of find a solution to this, mainly to figure out, okay, how can we actually shorten the gap between these two pieces of information, you know, between the information and the actual design software. And we looked at several ways we could utilize our Revit model to store that information. So Revit obviously is really good at storing dimensional and geometrical information, and also we can store things like text parameters and things like that. So we thought about, well, what if we just take our laptops out to the field and we enter a bunch of parameter information as we walk around all these rooms, and then we have that information in there. The problem is obviously parameters are quite limited in what information we can store, and when it came to the actual images, there was no real good way for us to embed that information into our model. 39,000 photos, obviously, that's not something we're going to try to put into our model. So we thought, well, maybe we can maintain kind of a separate database of information, and then have our model over here and just reference that information quickly as we're going throughout our model. But again, the scale of this project kind of necessitated that we cut down on that gap as much as possible. So ultimately what we ended up doing is building a prototype for a application that connected to our Revit model and organized information in the same way that Revit does, except it augmented it with all of these new data types. Like, for example, you know, we might have a light fixture element or a stair element or a door element or a room element, but now we're augmenting those elements with new data types like notes and conversations or files and photos, tasks, complex field data, things like that. So we're using the same references or context that our model uses to store information, but enhancing what we can actually store there. So I was kind of in the process of building this prototype as we were using it on the Capitol, which is always a really smart thing to do, be building something while you're using it. But that's really what it came down to, and it was incredibly valuable for us to have an instant feedback loop with our project team as we were actually building these tools. There's many a time when we were out in the field gathering information, and I had an iPad that I'm trying to quickly update on the trunk of my car while the rest of the team is out in the field gathering this information. So it was definitely like a messy process, but it was really valuable for us to understand what the problems were of the ultimate user and how we could try to solve them with the tool that we were building. So our prototype kind of consisted of these two different interfaces. One, a Revit add-in that actually connected to our model to pull and harvest information out of it as the model changed. And then a desktop and iOS app that allowed users to add information and also view the data itself. Ultimately, the Revit prototype essentially connected to specific categories within our model. And for the Capitol, it really came down to rooms and windows, pulling that room and window data out as we added things or subtracted things, and then spitting it out into this interface that we could use on mobile devices and on our desktop to add information. So you can see here basically what this ultimately looked like was a giant list of our rooms and our windows. And as you entered inside of those rooms and windows, you could see we had specific questions that we were asking about the data we were gathering, and also files, notes, and tasks related to that element itself. So originally we kind of set out to build this. We weren't really thinking about building anything bigger than just a solution for this project. And so a lot of these survey questions, were basically dictated by the project manager. Hey, this is the information that I want to know, and then I would go and kind of hard code that question in. What we realized pretty quickly as we were proceeding with this project was that if we abstracted this a little bit, abstracted these problems, there's quite a few different applications for connecting this contextual information back to our actual model. And so we set about, which I'll dig into here in a few slides, but we set about trying to figure out what that might look like as we were in the middle of this process. So ultimately, we started to reduce the gap between our building information and our actual model is within the add-in, we basically were monitoring people's position within the model, and as they would navigate in the model, a little side window of layer would pull up relevant information related to it. So when you click on room 1317, it's going to pull up all of the data along with all the photos, notes, and tasks related to that specific room. And so it made it super simple to be able to look at a room in our model and immediately see all of the photos related to it. And this was one of the biggest value adds to our project team, because they had all of that, 39,000 photos all right there as they were navigating their model. What we realized though as we went throughout this project is that photos like organized, if you click on a room and you see a pile of photos, it's incredibly helpful to see that information instantly, but we didn't have a great way to tell. You still end up in a position where you're not sure what direction these items are what direction these photos are facing or anything else like that. And so as we're going through this project, we started to build in more features related to smarter images. One of them being we started to gather we realized that we have these iPads and iPhones with compasses on them, and so we started to utilize that cardinal direction as a way to orient ourselves within our photos. So we would actually gather the direction of each one of these photos, whether it's south, west, northeast, etc. We also realized that there was a lot of our process of gathering this information that a user might remember that there's specific issues, like a window cracked on a specific window, or an area where there's brick needing to be repointed or something like that, but maybe forgot where that was within the building. And so again, as a benefit of the platforms we were building on, we started doing image analysis of all of the photos we uploaded, just passively, and then tagging those images with specific attributes themselves. So as a user took a photo, it got uploaded to our database, and then it went through an image labeling process where a photo like this, we would tag it with these photos. So it would assign probability to each of these keywords about items within the image itself. So, it would start to identify objects within the image, like vents. Would start to kind of predict whether this was on a floor or wall condition. It would identify materials and colors themselves. And then ultimately it would identify different attributes about the space or about the image. And it would also pick up on text, which turned out to be pretty helpful with different signage on the walls, especially when it came to like rooms and room numbers and things like that. It also identified emotion, which is completely not useful, but this is one of our architects who worked on the survey, and apparently he is purely joyful while doing the survey, which I find interesting. It's a tedious job for sure. So, but ultimately what that gave us is a library of images to where we could start to search keywords and then kind of reverse the way that we could find that image's context. So if we're looking for crack, we can find all the images with a crack and then see what room that's associated with or what window that's associated with. Ultimately, at the end of this project, and I shouldn't say the end of it, I mean, it's still ongoing. We've still got, I think, 6 years left in this project, but the initial survey of this information was completed. And again, we started looking at, okay, this was really useful from an efficiency standpoint on this project. How can we start to kind of abstract and find the value adds within this process, but help it to apply to really any project we're working on? And so we boiled it down to kind of these 4 key attributes of what was really effective for us as we went through this process. And it came down to the idea of a flexible platform, contextualized information, the real-time collaboration, and a Revit integrating into our design tools themselves like Revit. So the first was focused on a flexible platform, meaning that, at first we kind of started off like I was designing all these questions as the project manager was defining them, but we thought about, well, what if we built in these kind of ground level features and tools and field types that allowed us to take that information, allow users to use those features to create their own workflows. So we've got different data types like files and Revit parameters and date selectors and things like that users can then build out their own workflows related to facility audits, RFI tracking, all kinds of different workflow types. So this is just kind of a diagram of what you can kind of visualize this as is like a spreadsheet where each one of those columns represents a different field type. And then each row is a element within it. So if we're looking at our furniture, you might have specific columns with different field types that you were gathering. If we were looking at rooms, it might look completely different. So what this flexibility provided us with is a way to approach really all the different workflows that exist within the entire building lifecycle. So not only in design, but also in construction and operations, operations with work order tracking and asset management related to the context of your building became something, especially for us early on, that was really attractive to our users themselves. In design, we use this beyond just facility audits in punch lists and team coordination, tracking coordination issues within our model, things like that, which made it very useful for us. The second kind of key attribute as we developed this was this idea of contextualized information, meaning that the information that we needed to design wasn't located and positioned within our building. And so that's one of the main problems we were trying to solve with the capital. And so how we kind of approach this is this idea of tagging all of this information, and as you're navigating your model or navigating your PDF or whatever it is, we're pulling up relevant and pertinent information as you move around. That's vastly different than like the status quo of today. I mean, project information exists in email chains, file servers, different models, chat apps, task apps, things like that. And by no means are we saying that like Layer is a replacement for all of those platforms, but there's definitely project information in each of those platforms that would be better served, stored in the context of your building versus in these email strings or files buried in folders, things like that. So the way that we kind of think of organization of information is all, again, located within your building. So if you're clicking on a room like Office 103, there may be comments related to that. There may be photos related to it, existing conditions. There might be connections to other pieces of equipment or furniture within the room. A TV, for example, might contain cut sheets. The storefront of your building might have specific tasks for different project members, as well as like product specifications, things like that. A mechanical unit might have warranty information and maintenance reminders attached to it. Again, the difference is that we're trying to add context to all of this building information so it can quickly be found in the context of your building. So if we're looking at a task, the task portion of our application, you can assign tasks to team members and things like that. But again, those tasks themselves have context. So it doesn't just exist out there in the ether somewhere. It's connected now to an element within your building and details about that element itself. And this kind of finds it kind of is revealed in multiple different ways and features within our building, or I'm sorry, within our product. So we've got this idea of contextualized information that kind of permeates all the different aspects of our building with notes, files, tasks, field data, things like that. We also have documents that you can create and actually hashtag elements to mention elements and mention people directly within your notes. Like if you're taking meeting minutes or site observations or whatever else, it's a really quick way for you to be able to reference elements within your building as you're working in kind of this more traditional sense. The third kind of key attribute was that idea of real-time collaboration. On the Capitol, we had up to 4 or 5 people out in the field at a time. We had several people in the office working. And so the idea of all of this information happening and being added to this database in real time became really important for us as we went through our project. And so everything within the layer happens in real time. There's no syncing or saving. You see exactly where other users are at, what information they're editing, et cetera. So much like Google Docs, you kind of see where your team members are at throughout the project. And lastly, again, that last kind of key attribute for us was the connection to our authoring tools in design. So we have a Revit add-in that connects to your models, pulls out pertinent information, and allows you to layer contextualized information on top of those elements. So if you're looking at your rooms, you can go out in the field with your tablet or iPhone, take a bunch of photos, gather information about it. You can have conversations specifically related to it. And then when you come back to the office and you're in Revit, you can see as you navigate around your model, we're pulling up pertinent and relevant information as you go. So even if you're in the design phase of a project, just modeling, it's helpful to click on a specific element and quickly add a task that's automatically related back to that element itself. So that we found a lot of uses for this. And again, a lot of the uses look different based on what phase you're in within a project, for sure. And we also allow you to pull that data that you've gathered back into your model. So one of the biggest benefits for us on the Capitol was, well, we had 100,000 pieces of data. We had 39,000 photos. One of the biggest benefits was that all of this information was stored outside of Revit and not weighing our Revit model down at all. But there's some instances where you might want to bring that information back in to your model for schedules or color scheme plans, things like that. And so we actually allow you to set up mappings to map specific layer fields back to Revit parameters. And as you gather information, then that data automatically dumps back into your Revit model. So you can see here a schedule being populated by all of this information that we've gathered in the field. So it's one of the first solutions that, at least that I know of, that you can go out in the field, gather information, and then have it directly affect and impact your Revit model without having to do anything except hit a button. So I think that's about all I'll cover for now. I mean, right now we launched April 2nd of this last year as an actual product. Like I said, it's been an interesting road kind of getting to that point, but we launched April 2nd and have been focusing on this full time. We're a team of about 5 right now and growing. Yeah, if you're interested at all, you can find more at our website. I think I have a last layup. There we go. That's it. So if there's any questions, feel free to ask. But yeah, awesome. What did you say? It does not yet. No, one of our and depending on questions, what you'll hear a lot from me is we have a giant roadmap of features. I mean, we launched April 2nd. One of the things that we're working on is integrations. So Procore will be included in that, but we see opportunity for a ton of different integrations into this product. So.
How long have you guys been building it?
Well, so we started in earnest building it to bring it to market about 1.5 years ago. And then we launched April 2nd. About 2.5 years ago is when we started like the capital project and actually building the prototype. So we really had no intention to bring it to market until about 1.5 years ago. So yeah.
A lot of features seem room-based. What happens when you delete or put a room?
Good question. Yeah, you're right. Like I kind of focused on rooms just because like that's a use case for us with the capital, but you can sync any category within Revit, or you can actually create categories completely outside of Revit too. So if it's mechanical units or even like ducts or whatever it happens to be, you can sync that information back and then add contextual information to it. So like mechanical engineers, we've seen a lot of uses for mechanical units themselves, especially going out in the field and doing a condition assessment about the current state of things, zones, et cetera. So we manage the status of an element both in layer and in Revit. So if you're looking at your layer dashboard, you're seeing all of your elements within that category. But let's say you delete a room or a mechanical unit or whatever it is in your model. We surface that in layer to show you it was deleted in Revit. The information itself stays in layer. You have to intentionally delete that element in layer in order to get it to go away. So you can always like take that data and just reassign it to a new element and connect it in Revit. We're pretty flexible in how like you can start. So you can start without a Revit model at all and actually just be out in the field creating elements as you go. And then later we have an interface for you to actually connect that back to your model and different elements within your model. Does that answer your question? Okay, cool. Yeah.
Are there any built-in like reporting features in it, like any metrics or the ability to at least export and connect to something?
Yeah, good question. So we do allow you to export all of your information within layer to spreadsheets. So you can get a report based on filters that you set. That being said, we're working on different data types for our reports. So we want to be able to generate data sheets themselves in PDF form, and also just more robust filtering tools as well. So we're working on that now. But yes, you can get all of your data out into a spreadsheet format. So yeah. What did you say? So I was a project architect on the project. I was really focused on like, I mean, I actually was brought on to solve the data problem that we had. So I was a project architect. I mean, we were a small firm. We're working on projects of all sizes. I mean, like the capital is obviously a large project for us, but there's, you know, usually we're all juggling 5 or 6 different projects at a time. So I was brought on to help originally in the design phase and also kind of solve the data problem. And then I just quickly transitioned to only solving that data problem because it was bigger than what we thought. So, yeah. Yeah. Okay, let me be clear about that. That is a feature we're working on for the production side of things. We actually don't do that yet in the production environment. We did that for the capital. We see it as a valuable resource. We're working on bringing that to the production environment so far.
What was the vision analysis engine itself?
Oh yeah, good question. So we started with just Google's Vision API that allowed it to tag things automatically for us. We quickly actually developed some models in TensorFlow to train specific models ourselves to recognize specific, like cracks in the windows, things like that. So yeah, it kind of transitioned. It started with the Vision API, which is a super simple thing to, like, it does all of that for you, but we didn't get quite as specific results as we wanted. So we moved over to TensorFlow. Other questions?
See if there's any online.
Cool.
So see, I'm not seeing anything. And it's about 1 o'clock. So thanks for coming, everybody. There might still be some more pizza if you want to get something before you leave. And we don't have to leave immediately, so you guys can stay around and chat if you like. So thanks for coming. Thanks to our presenters, Tom and Zach. And see you next month, everybody.
Awesome. Thank you.